Good day, STEM students. Welcome back to Mampaisan's online classroom. Today, we are going to discuss Module 6, which is all about work, energy, and power. This module will be divided into 3 videos. The first video, this one, will be all about work. The second video will be about energy and energy conservation, while the last video, the third part, will be all about power. The objectives of this module are the following. Define work as a product of force and displacement. Determine the work done by a force acting on a system. Relate gravitational potential energy of a system to the configuration of the system. And lastly, solve problems involving work, energy, and power. As an overview, we have parts 1, 2, 3, and 4 as an outline, but parts 1 and 2, itong activity, work done or no work done, as well as the work done by a constant force will be included in this video, the part 1. And then the part 2 will be about the subtopic number 3, which is all about energy and conservation of mechanical energy. And then the last part, the third video, will be about part 4, which is power. Let's have the activity. So basically, I'm just going to show you different situations, and then we will determine if there is no work done or there is work done on the object. Here's the first one. Is there work done on the box? As you will see on your screen, we have a girl and she is pushing a box. And the answer here would be there is work done. Later, we will see if we will see the reason why or the explanation why there is work done on the box. Next, is there work done on the backpack? Here you will see that the girl is actually walking towards the east and then she is carrying her backpack. In this situation, there is no work done or work done is equal to 0. And again, later on, we will see why there is no work done on the backpack. On the third one, is there work done on the grocery bag? What is the girl doing? The girl is pushing up or pulling up the grocery bag upward, and she is exerting a force that is also upward. And here, there is work done on the grocery bag. Remember, katulad lang din sa net force tsaka no net force, pag sinabi natin there is net force, it means that the net force has a magnitude that is greater than 0. So, ganun din dito. Pag sinabi natin there is work done, ibig sabihin, the value of work is greater than 0 in magnitude. And then, kapag sinabi natin there is no work done, it means that the work done is equal to 0. Okay, yun yung ibig sabihin natin kapag there is no work done. Tapos, pag there is work done, okay, hopefully you remember that part. Okay, next, is there work done on the grocery bag? This situation is similar to the girl carrying her backpack. This time, the girl is carrying the grocery bag and she is walking towards the east. And here in this situation, there is no work done. Now let's see, based from our definition of work, what went wrong? Bakit iba yung situation? Pareho namang may ginawa si girl dun sa backpack, sa grocery bag, tsaka sa boxes. What makes the difference? What makes the other situation have non-zero work, tapos yung iba, 0 yung work done? Let's define work. In physics, work is defined to be the product of the magnitude of the displacement times the component of the force parallel to the displacement. So here, the condition is this. Hindi porke may force kang inexert ay may work done agad. Okay? For a force to be able to exert work or to do work, that force should be parallel to the displacement, or it should have a component that is parallel to the displacement. Later, we will dig deeper into those facts, but first, let's have the equation for work. work is W, that is not in boldface. Okay, kasi work is a scalar quantity. And then, we have here, you see, force here, tapos meron siyang parallel line sa ilalim. That means we are considering only the parallel component of force relative to our displacement. Diba kapag sa math, pag sinabi nating parallel, it means that the lines are going in the same direction, or endlessly until infinity, whatever happens, they will not meet. Okay? In work naman, when we say parallel, it means it is going in the same direction. Okay? So, ibig sabihin nito, dapat yung force should have a component that is going in the same direction as the displacement. In other words, or if we expand the equation, it would be work is equal to force times displacement cosine theta. Later, we will define each of them. But first, let's analyze the activity we have before. Ito, is there work done on the box? There is work done because the force is going in the same direction as the displacement. And then, remember or take note that when lines or vectors are parallel, the angle between them is 0. If you use your calculator based from our equation f d cosine theta, if you set the theta into 0, work will be greater than 0. Again, when anong tawag dyan? When you input cosine theta, given that the theta is 0, here, you will get a value that is actually positive 1, which will make our work equal to, greater than 0. So, may force, may displacement, tapos yung theta natin is 0, that will result to a work that is greater than 0. On the other hand, for the next example, the force is actually upward. To keep the backpack steady on the back of the girl, she is constantly exerting a force that is upward, kasi kung hindi siya mag-exert ng force na upward dyan, mahuhulog yung kanyang backpack. And this force is actually equal in magnitude as the bag's weight. Okay, lagyan natin ng arrow yung weight kasi para hindi kayo ma-confuse sa denotation natin for work saka para sa weight. So this weight, ayan, para magawa ni girl na mas steady yung bag niya sa kanyang likod, she should exert an upward force to counteract this weight, and it should be in the same amount as the bag's weight. Okay? Eh ngayon, saan naman yung displacement? The displacement is going to the right. Kasi, as you can see, although the force of the girl is going upward, there is no upward movement on the backpack. Hindi siya nag-move upward, although consistent yung force ni girl. And then, of course, as the girl is moving, the backpack is moving together with her. So, kung saan papunta si girl, doon din papunta yung bag, di ba? So, since the girl is going to the right, the backpack is also going to the right. But since the force is upward, the angle between the force and the displacement becomes perpendicular or equal to 90 degrees. Okay? If we use again the equation, work is equal to F d cosine theta, and then we set theta equal to 90 degrees, you will get work is equal to 0. Bakit? Kasi pag in-input mo sa calcu, ang cosine 90 degrees, you will get an answer that is 0. So if this part of the equation becomes 0, of course, i-multiply mo sa ng 0, the result will still be 0. Okay? So, the same goes here. Dito naman, the force is upward kasi binubuhat pa lang naman niya at hindi pa siya naglalakad. And then, the displacement is also upward. So, same direction, parallel, angle is 0. So, the work will not be equal to 0. There is work done. And then, here, again, the work done is 0 because the force is upward. That upward force, again, is equal to the weight of the grocery bag. And then, as the girl is walking, the movement or the displacement of the grocery bag would be towards the right. So, the force and the displacement will form 90 degrees, which will result to 0 work done. Okay? Hopefully, naintindihan natin yon. So, let's have the work done by a constant force. So, this time, now that we know the concepts behind work done in terms of physics, let's proceed with the computations. Okay? So, again, ito yung ating equation. Ito yung gagamitin natin. Ayan. Wherein, take note that work is a scalar, although it is a product of two vectors. Because remember, force is a vector and displacement is also a vector. Okay? Yan, let's define each. F, parallel, is the component of the constant force. F, parallel to the displacement. Again, component. So, ibig sabihin, hindi porke at an angle, hindi na siya, wala na siyang component parallel. Later, may picture tayo na magpapakita sa inyo kung ano yung ibig kong sabihin with that. Okay? And then the D is the displacement, and then the theta is the angle between the force and the displacement. Okay? So here, tingnan natin. Let's say we have here a father and then the father is trying to pull her daughter, but the force exerted is not a straight vector but a vector at an angle. Ayan, may certain angle siya na pinoform relative to the horizontal. Remember this force, if we're going to draw that force, ito yung F natin. Since it is at an angle, recall natin sa lesson natin ng vectors, kaya lagi kong sinasabi sa inyo that the lesson about vector is very important because the concepts about vectors will haunt you as long as you have physics as your subject. Okay? Yung iba nga sa inyo, di ba, sagot, bakit mahalaga na mag-aaral tayo ng vectors? Kasi nga, most of the things or some of the things that we study in physics are vectors. So we should know how to add them, no? So this force again has two components, the F sub x and then the F sub y. Ayan. Now this one is the angle, obviously here. Okay. Ayan. And then, anong tawag dito? The displacement is here, and then remember that the function that is associated with f of x is actually the cosine function. That's why we have this equation f d cosine theta. Actually, we can actually write it as d tapos f cosine theta. Okay lang din naman kahit paano mo siya isulat kasi pag mumultiplyin mo lang sila. Okay? Basta lagi magkasama yung cosine theta, baka mamaya gawin mo cosine df theta. Mali na yun, no? So, pwede mo siyang isulat na ganyan. Kasi nga itong fx natin, remember that is f cosine theta. Okay? Ayan yon. Doon siya nanggaling. So, pwede mo siyang isulat as that. Pwede rin naman siyang written as this. Okay? And then, let's have the SI units. Again, for displacement, hindi nagbabago. Kahit ano pang i-compute mo, laging meter ang SI unit ng displacement. For force, kahit anong klase pang force yan, the SI unit will always be Newton. And then, for work, the SI unit, take note ha, the SI unit is joule. And 1 joule or J is equal to 1 Newton meter. Ayan. Okay. So, ulit ha, ang SI unit natin for work is joule, and saan nanggaling yung equivalent niya na Newton meter? Kasi si force, ang unit niya ay Newton, tapos ang unit naman ni displacement ay meter. So, anong sinasabi sa atin nito? Always remember to convert all the displacement into meters, tapos convert all the forces into newtons. Kasi mamamali ka kapag hindi mo sila kinonvert. Okay? Next. So, dito meron na tayong example for positive work done. Pero bago ko ipakita kung paano siya isosolve, I will show you first how do we get the equations for force, ayan, for force, for displacement, and for theta, if they are the ones that we are going to find in the problem and the work is given. Kasi ang example ko dito, puro work done yung isosolve. Kaya tuturuan ko kayo kung paano kunin yung equation para sa F, D, at saka sa theta. Okay? So mag-start tayo sa ating general equation na F, D, cosine, theta. To get an equation for F, we divide both sides by d cosine theta. Yan, d cosine theta. So in this part, they will be cancelled. We will have F is equal to work over d cosine theta. Okay? So, that's for force. Paano naman kapag ang hinahanap ay displacement? O, ulit tayo sa work is equal to FD cosine theta. Okay? And then, this time naman, we divide both sides by F cosine theta. Ayan. F cosine theta. And then, cancel natin yung F tsaka cosine theta. We will get displacement is equal to work over F cosine theta. Paano naman kapag yung angle yung ating hinahanap? Okay? For that, again, we start with the general equation, FD cosine theta. And then, this time, we divide both sides by FD. Ayan. FD. Okay? And then, since cosine theta pa ito, to get theta, we use the inverse cosine, cosine na hindi tangent. Dito, iba to ha. So, we get the inverse cosine function and then the absolute value of this part. Okay? Work over FD tapos absolute value. Okay? So those are our equations. If the problem is asking you the force, the displacement, and the angle between the force and the displacement. Okay? So ngayon, erase na natin yan, no? Para makita natin ang katotohanan na napakaganda. Erase. Tagal mag-erase, ha? Dami. Wait lang. Inasan mo, girl? Ano ba? Ayan. Okay. So, let's proceed with positive work done. Sabi dito sa problem, a 35 kilogram package rests on the floor. How much work is done by the man who attached the cord to one of its edges at 40 degrees and pull it with a force of 40 newtons for a distance of 20 meters going to the right? The illustration is provided. So, meron tayong mga given, naka-red naman siya. Paano natin isusulat? The mass will be 35 kilograms. Although hindi mo kailangan yung mass dito, okay lang din naman na isulat mo siya at okay lang din naman na hindi. Okay, ano pala tandaan mo na mass yan? Siyempre may nakalagay na kilogram, di ba? And then the angle is 40 degrees. The force is 40 newtons and the displacement is 20 meters. Okay? So we are looking for the work done on the package. For the equation, its work is equal to FD cosine theta. Substitute 40, 20, and cosine 40. We will get 612.84 joules. Remember, it's not Newton meter, it's joules. Okay, so that's positive work done. And we have another here, which is also a positive work done, but this time it is maximum. So anong pinagkaiba? When we say positive work done, usually the angle is between 0 to 90 degrees, but it's not equal to 0 and it's also not equal to 90 degrees. Now, maximum work done is obtained when angle between force and displacement is equal to 0 degrees. Meaning, pag eksaktong papunta sila sa same direction. And then from 0 going to 90 degrees, the tendency is that the work done on the object becomes lesser or decreases. No? So as the angle approaches 90 degrees, the anong tawag doon? The work done on the object approaches 0 as well. Nagdi-decrease siya, okay? So this time, kung mapapansin nyo, dalawa lang yung given sa ating problem. However, in this part, we will have what we call the invisible given. Ito yung mga given natin. The mass, ayan, visible given yan. Tapos, yung displacement, visible given. So, ano yung mga invisible given natin? The angle and the acceleration due to gravity. So, why do we need the acceleration due to gravity and the mass? Mamaya malalaman natin. Oh, remember, ganito mga kabataan, sabi natin work has FD tapos cosine theta. So meaning we need a force, we need a displacement, and we need an angle. But look at the given, walang sinabing force. At wala ring sinabing angle. Ang sinabi lang is the displacement. So how will you get the force and how will you get the angle? The angle, you can infer from the illustration or kapag sinabi sa problem na nilift or pulled upward. Okay, yung object natin. Okay, tapos syempre kapag binubuhat natin yung bagay, the displacement is in the same direction as the force. Yan. Therefore, their angle will be 0 degrees. So, automatic yun, ha? Again, kapag yung problem involves lifting up or pulling up, not carrying up, okay, lifted up o kaya carrying up, ang kulit ko, no? Lifting up or anong tawag dito, pulling up, yung angle ng 0, o kaya kapag walang sinabing angle sa'yo, pero sinabi niya push towards the left, o kaya naman sinabi the force is going to the right and the displacement is also going to the right. So, yun yung indications mo that 0 yung angle between them. Okay? Next, paano naman tong G tsaka tong M? So, okay ka na sa angle. Gagamitin mo yung M tsaka yung G para sa force. Kasi here, in this situation, for the man pala, to be able to lift up this box or this package, this is the force exerted, he must counteract the object's weight. Okay? And remember that weight is equal to M times G. In this case, the F is equal to the negative of weight. Alam naman natin that weight is always negative dahil sa acceleration due to gravity. So, kung negative ang value nito, tas ini-negative mo pa, meaning the force will have a positive value. Okay? So, again, the force exerted when you are lifting up or pulling up an object should be equal to the object's weight, but positive because it is going on to the opposite direction. Okay? And then our required is the work done on the package. we can have this equation or another equation, which is work is equal to mg d cosine theta. This one is the shortcut. This one is the long method. Okay, wherein we substitute the mg for the force. We have a solution here. So kapag nag-long method ka, dalawa yung solution mo. Yung first step mo would be to solve for the force, and then the second solution would be to solve for the work done. Ito actually ay dapat joule. I'm so sorry. Ayan. So if we substitute, our final answer would be 617.4 joules. Ayan. Okay, so that's maximum work done. Hindi lang yung ano ha, upward yung pwede ring downward, basta pareho dapat ng direksyon, eksakto si force tsaka si displacement. So pwedeng pareho silang downward, pwedeng parehong eastward, tapos pwedeng parehong westward, as long as they are in the same direction. Always positive pa rin yun, no? And maximum, okay? Next, zero work done. A 35 kilogram package rests on the floor. How much work is done by the man who carries it for a distance of 20 meters? So, ayan, ito na yung keyword natin, carries, okay? So, here, if the boy carries it, again, the force he exerts must be equal to the weight of the object that is downward, but it should be positive because it is in opposite direction. And then the boy is already moving to the east. Okay. However, pareho na yung magiging direction ng displacement ni boy tsaka nung box. Kasi nga, kin-carry na niya yung box. So for the given, we will have the mass. Again, hindi na naman sasabihin yan sa problem sa inyo, yung angle tsaka yung G. Basta involved yung pag-carry o kaya naman involved yung pag-lift up. The force to be counteracted would be equivalent to the object's weight. That's why we would be needing the mass and the acceleration due to gravity. Pero kanina yung dun sa nauna, sa hila-hila lang, disregard din natin yung weight. Okay? Kasi hindi naman vertical lang yung movement. Yan. So, meron na tayong 90 degrees kasi nga, upward yung force, tapos yung displacement is forward. Actually, dapat may east dito eh. Okay? Next, the required would be the work done on the package again. And then, ulit, pwede tayong mag-shortcut. Pwede ulit siyang maging mg d cosine theta. Ayan. Pwede ulit two solutions. Ayan. Get the force and then get the work done. However, this is actually a problem wherein kahit may mga given siya, pag multiple choice yung tanong, automatic dapat alam mo na zero yung sagot. Kasi eksaktong 90 degrees ang angle between force and displacement. And remember, always remember that cosine 90 is equal to 0. Okay? Next. And the answer is work done is equal to 0. Ayan. Dito naman tayo sa ating negative work done. Ayan. Determine the work done by gravity on a hiker's backpack that has a mass of 15 kilograms and the height of the hill is 10 meters. Usually, the one that exerts negative work done is gravity. Kasi pag sinabing positive work done, it's work done on the system. Okay, on the system. Ayun na tayo, no? Chemistry na tayo, no? So, ulit, in simple words, kapag yung tao, yung nag-e-exert ng force or yung machine yung nag-e-exert ng force towards another object, that is positive work done. Kapag naman gravity ang nag-e-exert ng force, that is actually counteracted by a machine or a human being, the work done by gravity is negative because it is in the opposite direction as the work done by the machine or the object. So ito yung mga given natin. The mass is 15 kilograms and then the angle is, ayan, in equation form, 180 degrees minus theta kasi lagyan natin ng ano, no, ng anong tawag dito? 1 tsaka 2. So ito yung 2 natin. Let's say that is 2 and this one is theta 1, the angle between. So bakit naging 180 degrees minus theta 2? Kasi ito yan siya. The angle, remember it should be the angle between the displacement and the force. Ito yon. Ito yung displacement arrow natin. Katulad dito, paakyat daw siya sa hill. Ayan. That's the displacement arrow. Tapos ito naman yung ating weight equal to mg. So ito yung force that is ay the angle that we need. So saan galing tong theta? Galing siya dito. Ito siya. Ayan. So actually itong triangle na to, na form na yan, kamukha siya ng ramp ng hill. Ayan. So, ito yung angle natin. Tapos ito, since they are adjacent angles, equal sila in magnitude. Tapos ito, straight line yan pag binuo mo. So, para makuha mo tong angle na to, dapat 180 kasi kapag straight line, that's 180 degrees minus theta 2. Okay? And then the height is 10 meters. And the acceleration due to gravity is 9.8 meters per second squared. Siyempre, kailangan natin yan kasi ang pinag-uusapan natin is work done by gravity. Okay? Next. So, hindi pa yung displacement natin is yung height. Mamaya makikita nyo kung bakit. Okay? So, for the required work done on the package pa rin, not the package pala, on the backpack, no, hiker's backpack. Okay? Next, the equation would be work is equal to FD cosine 180. Theta 2 ito. Ayan, kasi ang equivalent nito, di ba, kanina is the theta 1, which is the angle between the force and the displacement. Okay? So, for the solution, kunin muna natin tong si cosine 180 na equivalent sa negative cosine theta. Saan nanggaling yan? Pakita ko muna, tapos balikan na lang natin to. Ayan, dito siya galing. Itong part na to is galing sa sine and cosine addition and subtraction formulas. Ito siya. Ayan, kapareho niyan, di ba? Ito yung isang angle, angle A, tapos ito naman yung angle B. So for that, cosine A minus B would be cos sin sin. Remember? Cos sin sin, sin cos sin, di ba? Mga ganun-ganun pinag-aaralan niyo sa pre-cal. Ayan. So, angle A is the 180 degrees and then angle B is the theta. So, if we substitute, ayan, magiging cosine 180 times cosine theta plus sine 180 degrees sine theta. If you are going to input sine 180 in your calculator, the result would be 0. And then when you input naman cosine 180, the result is negative 1. That's why here cosine 180 minus theta results to negative cosine theta 1 yan. Theta 2 pala. 2. Char lang yan. Theta 2. Okay? O, balikan na natin yung ating solution, no? Ayan. So, for the solution, syempre, substitute na natin kasi dapat ang nandito ay, ito nga, equivalent niya. Okay? So, ayan. Meron na tayong negative cosine theta. Sorry. Okay? So, bakit positive yung ginamit natin na force? Ay, force tuloy. Yung negative. Bakit positive yung ginamit natin na 9.8 meters per second squared. Okay, so this is to denote that the hiker is still doing work but the gravity is opposing the work done by the hiker. Because actually, pwede mo namang kunin na lang yung work done ni hiker tapos ini-negative mo lang, magiging pareho lang yung sagot mo, no? Pero dito, pinakita natin yung detailed solution. And then, isa pang nakapagtataka dito, tingnan mo siya, naging negative mgh. Hala, saan galing yun? Ito muna tayo sa mg. Yung mg, kasi nga 'di ba, yung force ni hiker should be equal sa force ni gravity, which is weight. So ayan na 'yon, yung mg natin, no? Tapos itong height, actually kung babalikan natin yung triangle natin kanina, ito yung angle theta, tapos ito yung d, okay? Tapos ito yung h. Okay? So, bakit naging h na lang yan siya dito? Si h is the adjacent angle. So, di ba, sa SOHCAHTOA natin, cosine of angle is equal to ka, adjacent over hypotenuse. So, medyo madugo tong negative work done. Pasensya na kayo, ganyan talaga buhay. So, ipag-substitute natin, adjacent adjacent side is h, tapos d is the hypotenuse. We cross multiply, ang magiging resulta h is equal to d cosine theta. Amazing, di ba? Ang galing ng math. Nakakatuwa. Ako lang yung natuwa, no? Ako lang yung natuwa sa tinuturo ko talaga. Okay. So, kaya naging h na lang yan siya dito. Kasi di ba wala tayong value ng theta? Pwede namang hanapin mo pa yung theta, pero mas matrabaho yon. So, kaya ang ginawa na lang niya dito is gumamit siya ng trigonometric powers. Trigonometric magic, no? Hindi. Trigonometric analysis and stuff like that. Okay? So, itong d cosine theta natin is h. Okay? Tapos itong negative, syempre, nilabas niya yung negative sign. And then we substitute and we get the work done equal to negative 1,470 joules. O, di ba? Ang dali lang niya. Sobrang dali. Maning-mani, no? Oo. Puro ganyan kaya ilagay natin sa exam. Char. Okay. So, yun. Hopefully, may natutunan tayo, mga bata. Thank you for listening and see you on the next video, which will be about energy and energy conservation.